This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 7, Comparative Refrigerant Performance per Ton. This one is about reading a single handbook table. It normalizes about 20 refrigerants to the same job, 1 ton of cooling, so you can line them up column by column. Refrigerating effect, compressor size, power, COP, and discharge temperature. We'll learn to read a row, compare 2 refrigerants, and see how the same fluid shifts across evaporator temperatures. Concept 1. One table, a fixed duty. Every row delivers exactly 1 ton, so the columns tell you what each fluid costs to do that job, not how much cooling it makes. The table comes in 3 blocks that share an 86-degree condenser and differ only in evaporator temperature. -25 for frozen storage, 20 for medium temp, and 45 for air conditioning. Always read the block header first. Concept 2. What the columns mean. Net refrigerating effect is cooling per pound. A big effect means little mass to move, so refrigerant circulated drops. Compressor displacement is the swept volume per ton. That is literally compressor size. Power and COP are the same energy fact seen twice. Higher COP, lower power for the fixed ton. Discharge temperature flags how hot the gas leaves, and compression ratio, condenser over evaporator pressure, is how hard the machine works. Displacement and COP drive most selection questions. Setup. The medium temp block, 20-degree evaporator, 86 condenser, 1 ton each. The rows run from high evaporator pressure at the top to low at the bottom, and displacement climbs as pressure falls. CO2 at 0.7, up through R22, propane to R134A at 4.3. Dense suction gas means a small compressor. Ammonia breaks the pattern. We'll see why next. And CO2 is the outlier. It's very high condenser pressure pulling COP down to 3.5. Solve. Ammonia versus R134A per ton. Ammonia's refrigerating effect is about 7 times larger, so it circulates far less mass, and its compressor is actually smaller, 2.5 versus 4.25, even at lower suction pressure. Its power is a touch lower, and COP a touch higher. The catch is discharge temperature, 180 versus 95, plus its B2 safety class from Lesson 6. R134A is the cool, benign alternative. And a check. COP times power is the same for every row, because every row is 1 ton. Solve. Part 2. 1 fluid, 3 duties. Follow R22 down the column across all 3 blocks. Only the evaporator changes. Lift it from -25 to 45, and COP more than triples, while compression ratio, displacement, and power all collapse. Same compressor, same refrigerant. The evaporator temperature is doing the work, which is exactly why you never compare rows across different blocks. Traps. 5 ways this bites. 1. It's a per ton basis. Every column but net effect is already per ton, so don't rescale it. 2. Never compare across blocks. A fluid's numbers depend on evaporator temperature. 3. COP isn't the only axis. Ammonia has the best COP and the hottest discharge. CO2 runs at 1000 pSAA. 4. The footnote is idealized. 0 subcool, 0 superheat. No line losses, perfect efficiency. 5. That asterisk means superheat required, the one exception to the 0 superheat rule. Quick recall. Every row is 1 ton, so read displacement for compressor size, COP for power, discharge for durability. The blocks are -25, 20, and 45-degree evaporators, all at 86 condenser. High evaporator pressure means dense gas and a small compressor. Ammonia's enormous effect gives it tiny mass flow and the top COP, at the cost of a hot discharge. Golden rule: match the block to the application, then compare fluids within it. Next up, Lesson 8. Refrigerant line sizing. The per ton table you just read feeds straight in. The suction, discharge, and liquid line capacity tables are also rated in tons, and you size a line by reading its capacity and correcting it. The only equations are the scaling pair and the condensing temperature factors. Everything's at prepengine.com. Cheat sheet, solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.